What happens when machines grow too powerful to understand? China isn't just building, it's bending the rules of engineering, speed, and even time itself. From the SLJ-900 iron monster that assembles bridges mid-air to an artificial sun burning 5 times hotter than the real one, these mega machines are rewriting the very limits of science. Stay with us as we count down the 15 China's mega machines just broke every rule of physics. Scientists can't explain it. The Iron Monster. China doesn't just build bridges anymore. It deploys machines that redefine construction itself. The most famous is the SLJ-932, better known as the Iron Monster. At 640 tons, 300 feet long, and nearly 30 feet tall, it isn't just a vehicle. It's a bridge factory on wheels. Where the US relies on cranes that lift one piece at a time, sometimes needing weeks just to assemble scaffolding, the Iron Monster grabs entire 800 to 950-ton concrete spans. Powered by 64 wheels grouped into 4 rotating trucks, the giant can slide sideways with surgical precision, something cranes can't even dream of. Fully loaded, it crawls at just 3 miles per hour. But speed here isn't about motion, it's about time saved. What once took months can now be done in days. The results speak louder than specs. On projects like the Yibin-Jinsha River Railway Bridge, travel between Sichuan and Guizhou dropped from 12 hours to just 3. It's also been used to stitch together high-speed railways across Inner Mongolia and beyond, as part of China's 30,000-mile high-speed network. And efficiency doesn't just mean speed. Monster delivers bridges that are safer, cheaper, and longer-lasting. Each unit can lay up to 1,000 bridge spans before retirement, a lifespan of about 4 years. Western engineers once doubted whether such a machine could even work. Today, the Iron Monster has made traditional cranes look like relics from another century. China's biggest TBM. When most countries dig tunnels, they reach for drills, dynamite, and patience. In China, they built a machine the size of a skyscraper and sent it underground. This is Jinghua, the largest tunnel boring machine China has ever produced, a 16.07-meter mega slurry TBM built by CRCHI. At 500 feet long, 4,300 tons heavy, and taller than a 5-story building, it's less a machine than a moving city beneath the earth. To put that in perspective, in the US, many TBMs top out at 20 to 25 feet across. Jinghua? It carves a path wide enough to swallow a 4-lane highway in one pass. It's a tunneling leviathan designed for one of Beijing's most ambitious projects, the East 6th Ring Road reconstruction, a 10-mile tunnel cutting through sand, silt, and waterlogged soil that would collapse under conventional methods. Its secret isn't just size. A slurry system holds back waterlogged soil, the telescopic drive keeps it steady, and it can even swap cutter tools without stopping. While ordinary TBMs drift or collapse in shifting ground, Jinghua keeps a straight line with pinpoint accuracy. These systems aren't luxuries. They are survival mechanisms. The geology around Beijing is a nightmare, the kind of conditions where traditional TBMs would choke or drift off course. Jinghua, however, holds its line with millimeter accuracy, carving through terrain that once made tunneling impossible. And this is only the latest in a string of giants. Since 2020, China has rolled out multiple 15-meter class slurry TBMs for river crossing tunnels in Hangzhou and Changsha. Each one pushes the limits of what's possible underground. For decades, China relied on importing expensive slurry-balanced TBMs from Europe and Japan. Today, it not only builds its own, but it also exports them. Globally, only 2 TBMs larger than 17 meters exist, both in the West. Jinghua may not hold the record for absolute size, but it proves something far more important: that China has closed the gap and in some ways surpass the world's best. Kunlun Transport Erect. Bridges across the sea were once the kind of projects that demanded fleets of cranes, barges, and years of labor. But China built a single machine that can lift, carry, and place an entire 1,000-ton, 40-meter girder like it's nothing. Its name is Kunlun, the world's first transport erect machine of its kind. Kunlun was built for the Meizhou Bay Cross-Sea Bridge, part of the Fuzhou-Xiamen high-speed railway, China's first high-speed line to run across the ocean. That project shrank the trip between two coastal cities to less than an hour. Instead of using 3 different machines to transport, lift, and install girders, Kunlun does it all. Picture this: a steel giant hauling a 131-foot concrete beam, heavier than a warship's hull. It inches forward with perfect accuracy, locks onto the next pillar, sets the girder in place, then drives across its own work to do it again. That's how an ocean bridge grows, span by span, in weeks instead of years. And Kunlun isn't just strong, it's smart. It can climb ramps as steep as 30 degrees and handle tight curves where ordinary machines would stall. The brains matter too. Kunlun automatically moves girders through tunnels, tracks their condition in real time, and syncs with control rooms to keep every lift safe and precise. The result? Construction that's 25% faster and 20% cheaper than traditional methods. But the real magic is what it means for trains. By laying 131-foot, 1,000-ton girders, Kunlun builds bridges so stable that high-speed trains can cruise smoothly at 250 miles per hour. On routes like the Zhengzhou-Chongqing line, where more than 90% is bridges and tunnels, machines like this make it possible to fly through mountains and valleys at full speed. Cross-sea bridges used to be once-in-a-generation projects. With Kunlun, China builds them like clockwork. A machine that lifts 1,000 tons at a time doesn't just build bridges, it builds speed itself. XGC 88,000 crawler crane. China built a machine that can raise 4,000 tons. That's the weight of a fully loaded Airbus A380. Meet the XGC 88,000, the world's most powerful crawler crane. This thing is a giant. It stretches nearly 600 feet long, stands over 350 feet tall, and weighs more than 5,300 tons. Its boom alone can reach almost 500 feet into the sky, taller than most skyscrapers. Watching it move feels like watching gravity get bent out of shape. Since it rolled out in 2013, the XGC 88,000 has been showing off around the world. In Jiangsu province, it lifted a 2,600-ton reactor, finishing the job 10 days ahead of schedule. In Shandong, it installed the world's biggest offshore wind turbine, sliding a 1,000-ton nacelle into place almost 600 feet above the ocean. That single turbine can power 55,000 homes for a year. But here's what makes it different. It's not stuck in one spot. Unlike other mega cranes that run on rails, this one crawls on huge tracks with a second unit carrying its counterweight, nearly 3,000 tons of ballast, right behind it. Together, they move like a tag team, keeping balance while lifting loads that seem impossible. Inside, the operator's cabin is the size of an office, complete with air conditioning and even a sofa. But from that chair, one person controls the mightiest crane ever put on wheels. It can be taken apart, moved, and reassembled for oil refineries, offshore platforms, and power plants. Over the last decade, the XGC 88,000 has worked on more than 20 mega projects, both in China and abroad. It's lifted over 200,000 tons in total, breaking records again and again. CPG 500 track laying machine. When most countries lay railway tracks, it's a slow grind, a few hundred feet at a time, endless workers, and weeks of sweat just to cover a short stretch. But China built a machine that turns that crawl into a sprint. The CYP 500 is a track-laying giant that can lay down almost 7,000 feet of track, more than a mile, in just one day. To see its power in action, look at the China-Laos Railway, a 257-mile line running from the Lao capital of Vientiane to the Chinese border. In 2020, the CYP 500 laid its very first rail there, a single stretch of 1,640 feet, the longest ever installed outside China. For Laos, once cut off by mountains and borders, it marked the beginning of becoming a land-linked hub at the center of Southeast Asia. Compared to older methods, the difference is night and day. In the US, track laying is often still done with smaller gantry cranes and long crews working section by section. That means weeks to cover ground that the CYP 500 can finish in hours. And while traditional methods often demand constant realignment, this machine locks rails in place with millimeter accuracy, ensuring that high-speed trains can later glide over them at 100 miles per hour without a bump. The terrain made the challenge even greater. Nearly 124 miles of tunnels and 38 miles of bridges had to be built across mountains and rivers. Add in the global pandemic, and the project should have faced years of delays. Instead, the CYP 500 kept pushing the line forward day after day, with round-the-clock crews and almost no downtime. By the time the railway opened in 2021, travel across Laos had been transformed. What once took days on rough, winding roads could now be done in hours on sleek, electrified trains. And the secret weapon was a machine that did what no human workforce with cranes and hand tools could ever match: lay rail at the speed of a nation on the rise. XDE 440 haul truck. Mining trucks are already the giants of the construction world. But China has built one so massive, it makes the rest look small. This is the XDE 440, the world's largest rear-wheel drive mining truck. Standing nearly 3 stories tall and weighing more than a Boeing 747, it can haul 400 tons of rock in a single load. To put that in perspective, the most common haul trucks in American mines carry about 240 tons. The XDE 440 moves almost double that in one trip. It's like carrying the weight of 2 fully loaded passenger jets every time it rumbles down into the pit. The truck was designed for global mining giants like Zijin Mining and China Mine Metals, companies that run copper and gold mines from South America to Africa. In Serbia's Kukari Peki copper mine, for example, fleets of these machines are moving mountains of ore faster than ever before. And in Peru and Australia, where ore has to travel miles from pit to processing plant, a machine like this saves both time and cost on every run. What makes the XDE 440 unique isn't just the size. To handle its record-breaking payload, XCMG engineers had to invent the largest wheel reducers and the strongest wet disc brakes ever built. Together, they give the truck traction equal to a 16-car high-speed train. That kind of power keeps it steady on steep grades where smaller trucks would strain or stall. The XDE 440 is also part of China's push for greener, smarter mining. It uses an electric AC drive system for efficiency, real-time monitoring to prevent breakdowns, and safety features. Each truck can run over 7,000 hours a year with more than 95% uptime, numbers most fleets can only dream of. Zoomlion 3,200-ton crawler crane. Most crawler cranes in the world can lift a few hundred tons, but Zoomlion built one that can handle 3,500 tons. That's more than 10 times what most cranes can manage. This monster is the Zoomlion ZCC 3200NP, one of the most powerful crawler cranes on Earth. Its biggest moment came at a nuclear power plant in China. Engineers had to place a massive 340-ton steel dome nearly 150 feet in the air with millimeter precision. One mistake, and the entire project would be delayed for months. Zoomlion's giant lifted the dome, held it steady, and set it perfectly into place. A job that smaller cranes would have needed multiple machines, weeks of rigging, and far more risk. This crane did it in a single controlled lift. What makes it different isn't just the raw power. The crane is fitted with advanced control systems and sensors that keep the load balanced within just a fraction of an inch. For something that weighs more than a jumbo jet, that level of control is staggering. SD90C5 Dozer, Shantui's monster dozer, a machine designed for the toughest mines and biggest earthworks. This beast weighs about 117 tons with close to 950 horsepower under the hood. It's built to do what smaller dozers can't: push entire hillsides like they're sand piles. One of its biggest tests came in a massive open-pit gold mine in China. Normally, mines like this use fleets of mid-sized dozers to strip rock and clear haul roads. Dozens of machines, hundreds of man-hours. But the SD90C5 replaced many of them, chewing through overburden in single passes where other dozers would need several. What took hours before, this machine did in minutes. That's the difference. In the US, even the heavy-duty bulldozers usually top out pushing around 100 tons per pass. The SD90C5 doubles or triples that. In places like Inner Mongolia and Shaanxi, it's already been used in giant coal and mineral pits, working side by side with trucks like the XDE 440 haul truck. Together, they form the muscle of a mining system where every minute counts. Watching the SD90C5 at work feels almost unreal. Entire ridges flattened, valleys reshaped, and mountains pushed aside. It isn't just a bulldozer. It's a land reshaping machine built to turn the impossible into just another day's work. Artificial sun. The sun's core burns at about 27 million degrees Fahrenheit, hot enough to power a solar system. But in China, scientists built a machine that runs even hotter, and they've kept it burning for minutes at a time. They call it the artificial sun. Officially, it's the Experimental Advanced Superconducting Tokamak, or EAST, a massive donut-shaped reactor that uses magnets to trap plasma, the same superheated matter that powers real stars. In 2022, EAST hit 158 million degrees Fahrenheit, nearly 5 times hotter than the actual sun, and kept it stable for over 17 minutes. That record leaves others in the dust. In 2003, France's Torre super reactor held plasma for just 6 minutes. In the US, the National Ignition Facility finally achieved fusion ignition in 2022, producing more energy than it consumed, but only for a fraction of a second. The UK has also set records in energy output, but again, only for seconds. EAST's achievement isn't about a quick flash. It's about holding the fire steady, long enough to matter. Why is this important? Because nuclear fusion is the holy grail of energy. Unlike nuclear fission, which splits atoms and leaves behind radioactive waste, fusion fuses hydrogen atoms, releasing near-limitless clean energy with no long-term waste. A reactor powered by fusion could, in theory, run a city on just a few gallons of seawater fuel. Gravel crusher. China's push for mega machines has turned heads worldwide, and one standout is the gravel crusher, an industrial powerhouse that's changing the game for construction and mining. But what makes this machine so groundbreaking? At its core, a gravel crusher is designed to take large rocks and break them down into smaller, usable materials like gravel and sand. These crushed materials are essential for infrastructure projects. Think highways, bridges, and urban developments. What makes these crushers so impressive is not just their sheer size, but their efficiency. They're built to handle massive loads, reduce material waste, and speed up construction timelines. There are several types of gravel crushers, from jaw crushers that apply strong compressive force to cone, and impact crushers that refine the material even further. Each plays a crucial role in ensuring uniformity, durability, and strength in the final product. For industries, this means consistent quality and reduced costs, a major advantage in large-scale projects. The benefits extend beyond efficiency. Stone crusher plants can be designed to operate continuously with minimal manual intervention. Automation features allow operators to monitor performance, adjust settings, and maximize output with ease. On top of that, modern gravel crushers are built with sustainability in mind. They help recycle construction waste, turning debris into reusable materials and reducing the environmental footprint. So while these mega machines may not literally defy physics, their performance feels close to it, delivering speed, power, and precision that traditional methods simply can't match. And with China scaling production, these crushers are setting new global standards. World's biggest wheeled crane breaks barriers. Wheeled cranes are supposed to be versatile, but they've always had a limit. Too small to rival crawler cranes, too light for the heaviest jobs. Until China built the XCA 4000, the world's largest wheeled crane, with a lifting capacity of 4,400 tons. Its debut came at a 200-megawatt wind farm in Hebei Province, where engineers faced turbines taller and heavier than ever. The nacelle alone weighed 286,000 pounds, the blades stretched over 312 feet each, and the hub another 88,000 pounds. All of it had to be lifted and fixed together nearly 530 feet above the ground. The XCA 4000 raised them one by one, completing the assembly in a fraction of the time smaller wheeled cranes would have needed. What makes it different is how it breaks the limits of its class. Typical all-terrain cranes max out around 1,200 tons. The XCA 4000 is more than 3 times stronger, and it doesn't stop at strength. The crane's control system uses dozens of onboard sensors to monitor load, wind, and stability in real time, adjusting automatically to keep lifts safe. By solving issues like reduced performance at high altitudes and tight clearance beneath turbine hooks, the XCA 4000 cuts turbine installation times by 20 to 30%. In the past, projects like this would require crawler cranes hauled in on heavy transports, weeks of setup, and far more cost. The XCA 4000 rolls in on its own wheels, sets up faster, and does the same job with record-breaking efficiency. Ganghang Ping 5. Offshore wind farms are getting bigger, and so are the machines needed to build them. Ganghang Ping 5, China's newest offshore wind installation vessel, a floating giant designed to carry, lift, and install the world's largest turbines in deep water. At 483 feet long and 160 feet wide, this vessel is as big as a football field and as wide as a city block. It can carry 2 complete 20-megawatt turbines at once, or even a single next-gen 26-megawatt turbine, each one taller than a 90-story skyscraper once fully assembled. Its main crane can lift 2,000 tons, enough to hoist an entire small office building, to heights of over 550 feet above the deck. For comparison, most older jack-up wind vessels max out at around 1,000 tons. Ganghang Ping 5 doubles that, making it one of the strongest offshore cranes in operation today. Its dynamic positioning system keeps it steady even in strong currents, while an intelligent ship control system, the first of its kind in China, monitors stability, power, and crane operations in real time. The vessel's first assignments are in China's new 200-megawatt wind farms, where turbines are only getting bigger, heavier, and taller. Compared to older European jackups, which often required support ships to shuttle blades and nacelles, this vessel carries everything on board and raises it into place in a single campaign. It's faster, steadier, and purpose-built for the new era of mega turbines, MGSA blow molding machine. Not every mega machine towers over skylines or tunnels under mountains. Some change the world in ways you touch every day. China's MGSA blow molding machine may not look like a giant, but in the world of manufacturing, it's a beast. This machine takes raw plastic and reshapes it into bottles, jars, and containers with unreal speed and precision. Older semi-automatic systems required heavy manual labor, one cycle at a time. The MGSA, it can pump out over 2,800 bottles per hour, each one identical down to fractions of a millimeter. Where older systems struggled to keep pace with mass demand, this machine runs like clockwork, day and night. MGSA makes it look effortless, keeping the cycle smooth while producing containers strong enough for carbonated drinks and precise enough for pharmaceuticals. And that's why it matters. Imagine global supply chains without a machine like this. From water bottles on supermarket shelves to medical packaging in hospitals, mass production at this scale isn't possible with older blow molders. Jianghai Tunnel Boring Machine. Tunneling under a river is one of the hardest challenges in engineering. Water pressure, shifting silt, and soft soil can swallow smaller machines whole. But China's newest giant was built for exactly that fight. Meet Jianghai, the country's largest tunnel boring machine. A steel leviathan 476 feet long, weighing 11 million pounds, with a cutter head almost 55 feet wide. Its mission: to carve out the world's longest underwater highway tunnel beneath the Yangtze River. The Haitai Yangtze River Tunnel, part of a 24-mile highway, will connect Nantong and Suzhou in Jiangsu Province. At its deepest, the tunnel runs 250 feet below the riverbed, through terrain so unstable that traditional tunneling would be impossible. Compared to earlier TBMs, like the 52-foot Jinghua used in Beijing, Jianghai is even larger, more precise, and more intelligent. It can chew forward 40 to 50 feet a day, while keeping its path within less than half an inch of accuracy. What makes Jianghai unique is its intelligence. Built into the machine is a database of past tunneling problems, letting it learn from earlier projects and even suggest solutions to operators in real time. It's like giving a mega machine a memory, so every mile it digs is smarter than the last. For China, it's more than a machine. It's proof that its TBM industry, once reliant on imports, now leads the world in size, speed, and innovation. China's new aircraft carrier. For decades, the U.S. Navy's supercarriers ruled the seas. No other country had the technology to match them. Until now. China has launched the Fujian, its newest aircraft carrier, and the first in the world, outside America, to use electromagnetic catapults to launch jets. This is China's third carrier, but its first true supercarrier. The Liaoning, China's first, was a refurbished Soviet ship. The Shandong, its second, was the first built at home, but still used the old ski jump ramps that limit how many jets can fly and how much fuel or weapons they can carry. The Fujian changes all that, at 1,033 feet long and displacing nearly 80,000 tons. It's in the same weight class as America's Kitty Hawk carriers, but with technology far beyond them. The electromagnetic catapult system, similar to the one on the U.S. Navy's Gerald R. Ford, lets planes launch faster, heavier, and more frequently. That means fighters with full weapons, loads, early warning planes, and even fixed-wing drones can all take off from Fujian's deck. The difference is massive. Older carriers with ski jumps might manage a few dozen launches a day. Fujian could double that tempo. The Fujian began sea trials in 2024, part of a massive naval modernization campaign that's seeing Beijing spend over $1.4 trillion on new military hardware by 2028. For decades, analysts said only the U.S. could build carriers like this. Fujian proves that the era is over. Thanks for watching. If this blew your mind, smash that like button, subscribe for more wild science updates, and drop a comment. What do you think about China's mega machines?